Hi students, in today's session we are going to discuss about sorption pumps. Sorption pumps belong to the category of dry pumps. Now dry pumps are those which do not require an oil for its functioning. In the previous session we had discussed about oil sealed rotary vane pumps which required an oil which was used as both a lubricant and also to seal the clearances between the moving parts of the pump. Unlike that, sorption pumps do not require any oil and they belong to the category of dry pumps. Now sorption pumps are used to create pressures as low as 10 raised to minus 2 to 10 raised to minus 3 torr. That is, they are used to create low and medium vacuum. As a result, they are most predominantly used as 4 pumps. In the last session, we had discussed about 4 pumps or roughing pumps. They are used initially to reduce the pressure of the vacuum system to nearly 10 raised to minus 2 to 10 raised to minus 3 torr. That is, it is used to create a low vacuum inside the vacuum chamber which is necessary for a fine pump to start functioning. A fine pump is a pump which is used to create high or ultra high vacuum. So sorption pumps are generally used as 4 pumps for fine pumps like getter pumps and ion pumps. Now its principle. Before discussing the principle of the sorption pump, let us know what the term sorption means. Now whenever a gas comes in contact with a solid, the solid takes up some amount of this gas. And this process is known as sorption. That is, the solid will take up some amount of gas which comes in contact with it. Now sorption can occur in 2 ways. The solid taking some amount of gas can take place in 2 ways. One is the gas molecules will be simply held on the surface of the solid physically by means of a physical process. The gas molecules are held onto the surface of the solid and that is called adsorption. That I have written here. It is called adsorption. That is, gas molecules are adhered to the surface of the adsorbent. Adsorbent means the solid here, onto which surface the gas molecules are adsorbed. That is called the adsorbent. So the gas molecules are held onto the surface of the adsorbent by physisorption. Physisorption means the forces attracting the gas molecules to the solid may either have a physical origin or a chemical origin. If the origin of the forces is physical, that is, they are simply held on to the surface by a mutual force of attraction, means the process is belongs to physisorption. So adsorption is a physical process, so it belongs to physisorption. So the principle behind the working of a sorption pump is adsorption. Now the next manner in which gas molecules are held onto the solid is by absorption, or the manner in which the solid takes up the gas molecules is by absorption, which is familiar to all of us. That is, the gas molecule enters into the bulk of the solid and it gets absorbed. Okay, so the principle behind the working of a sorption pump is not absorption, it is adsorption. Okay, the physical process of adsorption. Now, initially when the sorption pump was discovered, the adsorbent material used was charcoal. Now charcoal is highly porous and which enables a large amount of gas molecules to be adsorbed onto its surface. But nowadays, together with charcoal, naturally occurring and synthesized zeolites are used as adsorbent materials. Now what are zeolites? Zeolites are porous aluminum silicates combined with one or more metallic elements. So this represents the composition of a silicate. So it is of a zeolite, that is an aluminium silicate in which is combined with one or more other metallic elements. Now in the zeolite, the atoms are arranged in tetrahedral forms about the aluminium and silicon atoms. Now this tetrahedra are arranged in complex three-dimensional forms by sharing oxygen atoms, so that a large number of cavities or pores are formed where the gas molecules can get adhered, or where the gas molecules can get adsorbed. Now we also know that any material will adsorb a large amount of gas molecules when it is cooled. That is, when the adsorbent materials are cooled, it will have the capability to adsorb a large amount of gas molecules. So that principle also is made use of in a sorption pump. That is, a sorption pump requires liquid nitrogen to operate. So let us see its construction and working. So sorption pump consists of a cylindrical canister, that is this one, a canister inside which the adsorbent is taken. Charcoal or zeolites are taken, and it is brought in contact with liquid nitrogen. This region is filled with liquid nitrogen, that is, this is a Java cooled with liquid nitrogen. So that when the gas molecules enter into this pump from the vacuum system, the gas molecules are very effectively adsorbed onto the surface of the sorbent material. Now the gas molecules are trapped on the surface of the sorbent material, which is cooled to liquid nitrogen temperature, and these molecules get released when the sorbent material is brought back to the normal temperature conditions, or when the sorbent material is brought back to the ambient temperature conditions. What happens when the sorbent material is having the liquid nitrogen temperature? The gas molecules are very effectively adsorbed onto the material of the sorbent material, and when the adsorbent or the sorbent material is brought back to the normal temperature condition, the gas molecules adsorbed on it gets released. So the sorption pump always need to be periodically regenerated. Periodically regenerated means it has to be brought to the normal temperature, and the gas molecules adsorbed on its surface have to be allowed to release, or they must be given an opportunity to get released, so that the sorbent material can adsorb more amount of gas molecules. Okay, so this is actually a drawback. That is, this periodical regeneration is required, or a routine regeneration is required for the sorption pump. So this is actually a demerit or a drawback of the sorption pump. However, sorption pumps are very clean, non-contaminating fore pumps or roughing pumps, where, and they are used in situations where low throughput applications are required. And it's also noted that whenever the sorption pump is saturated, that is, the sorbent material has adsorbed the maximum gas molecules that it can adsorb, then I told you regeneration has to take place. So the gas molecules contained inside the pump will be capable of developing several atmospheres of pressure. That means the gas molecules, if it is released from the sorbent material, it can produce several atmospheres of pressure. One atmosphere of pressure is our normal pressure. So the gas molecules adsorbed on the surface of the sorbent material, if released, will be capable of producing a very large pressure here. So there is always a need for a safety valve or a pressure relief valve in this pump, so that accidents can be avoided either during routine regeneration or during an accidental regeneration. Okay, so I hope the sorption pump is clear to all of you. So as I told you, sorption pumps are dry pumps used to create low and medium vacuum, and the physical principle here is adsorption, and the adsorbent material is kept at very low temperature, that is liquid nitrogen temperature, and the sorbent material needs to be periodically regenerated so that it can adsorb more and more amount of gas molecules. I hope the sorption pump is clear to all of you. Thank you.